info, you can check it out the I button. So let's get into the video. Today we are going to discuss about logarithms. Okay, these logarithms were introduced by John Napier. Okay, before introducing of logarithms, there would be difficulty in solving the calculations. Okay, so after this, John Napier introduced logarithms to simplify the calculations. Okay, this John Napier introduced logarithms to simplify the calculations. Before that, there would be difficulty in calculations, and they would be, the mathematicians would be taking 1 to 3 days for solving only one sum. Okay, one question. So here this John Napier introduced logarithms for the first time and made the calculations simply and easy. Okay, so now let's know what is logarithms. Okay, before that, we know the exponential forms, right? When number is okay, let's take an exponential form number. Okay, 2 to the power of 5 is equal to 32. This is in exponential form. So here as you see, when 2 is multiplied 5 times, we'll get 32, right? So here now let's write which power of 2 is 32. Okay, here which power of 2 is 32. Okay, now here 2 is raised to how many times to get 32? We should find that. Okay, what is the answer? 5 times, right? So we should write this in logarithmic form. This logarithms can also known as log. Okay, we can write log in calculations before instead of writing logarithms. Okay, this 2 to the power of 5 is equal to 32. So here 2 is raised 5 times and then we'll get 32. So here let's write first log. We should write the answer first. Log 32. This 32 will become as a logarithmic number, and log 32 to here what is the base? Here in the exponential form, here the base is 2, right? So here also that will be the base. Log, how we should write this? Log 32 to the base 2. Log 32 to the base 2 is equal to the exponent. The exponent for the exponential form statement will be the answer for this 5. Here what is the exponent? 5. So here we write. So first understand this. Here we added a log for this exponential form, then it becomes log. This answer will become as a logarithmic number, log 32. Here what is base in exponential form? 2. So here that will become as 2. How we should read that? Log 32 to the base 2 is equal to 5. 5 is the exponent. Okay, clear? So now let's take another example to understand more clearly. Okay. 3 square is equal to 9. So now let's write this exponential form number in logarithmic number, in logs. So log, this 9 will become as a logarithmic number, right? 9 to the base 3 is equal to what here? 2, right? Do you understand? Log, this logarithmic number will be 9 and the base will be base here also, and this exponent will go to the RHS. Log 9 to the base 3 is equal to 2. Okay, let's take another example. Okay, 5 square 25. Okay, here let's write this in logarithmic form. Log. Here the answer is what? The answer is 25. So this 25 will become as logarithmic number, and here the base will become this 5. The base is right here, the base is 5. So now we should write this as base. In the corner of G we should write the base, and here we should write straight to the 25, and here the square will become as the answer. Log 25 to the base 5 is equal to 2. Okay, let's take another number. Okay, let's take about the number. Yeah, 2 to the power of 4 is equal to 8. Is it right? No. 2 cube is 8, right? Okay, 2 cube is equal to 8. So now you should write this in logarithmic form. Log, this 8 is larger number, so here log 8 to the base 2 is equal to 3. Okay, this will become as 3. And let's take fifth one. Okay, yeah, let's take 6 square. 6 square is what? 36. So here let's write this is log 36 to the base 6 is equal to 2. You understand? Here nothing is there. First we should write log. Okay, first we should write log, and next the number, the RHS number should, okay, the RHS number, first we should write the log, and next the RHS number, and then the answer. This answer will become as the logarithmic number. Then this in the exponential form base will become as the base for logarithmic number also, without exponent. Okay, the exponent will become as the answer. Okay, so now let's reverse this. Okay, so now let's write log. So now we should, I'll write the logarithmic numbers, and now we should find the exponential forms. Okay, first before reversing, let's know this theoretically. Okay, let's know the definition for this logarithms. These logarithms are the quantity to which a number is raised. Number is this result. This is known as result. Number is raised to get a result is logarithm. Okay, you understand the quantity. Okay, now let's assume this 6 is a quantity. To here that 6 is raised to 2 to get a result 36, and this is logarithm. So now we should write this in logarithmic number, logarithmic form. Then this will be logarithm. This is known as, this is the definition for this. And here theoretically, let's write this theoretically by using variables. A to the power of x is equal to n, then log n to the power to the base is equal to x. Do you understand here? Here we didn't. So here in the place of 6 we took a, in the place of 2 here we took x, then in the place of 36 we took here capital N. Then now we should write that in logarithmic form. So here we wrote log, and the result will become as a logarithmic number, and this base will become as a base for this, and here x will become as the result. Do you understand? So now let's do the reverse, means let's take logarithmic numbers and now find the exponential forms. Okay, let's take first one, log 100 to the base 10. Okay, log 100 to the base 10. So now this we should find this 10 is raised how many times to get 100. Okay, let's check it out. 10 to the power of 1 is equal to 10. 10 square is equal to 100, right? Here the 10 is raised 2 times to get 100. Let's write this 2. That will be answer will become as 2. Okay, here we should find where the 10 is raised how many times to get 100. Okay, so here we shown the exponential form, right? So now let's take another number, log 25 to the base 5. So now this 5 is raised how many times to get 25? How many times? Let's check it out. 5 power of 1 is equal to 5. 5 square is equal to 25. Okay, here the 5 is raised 2 times to get 25. Here the value will be 2. Okay, let's write another number. Okay, now let's take either. Okay, log 625 to the base 5. So here we should find 5 is raised how many times to get 625. Let's check it out. 5 to the power of 1, 5. 5 square is 25. 5 cube is 125, and 5 to the power of 4 is 625. Okay, here as you can see this 5 is raised 4 times to get 625. So now let's take another, log 36 to the base 6. Here we should find the 6, how many times the 6 is raised to get 36. 6 power of 1 is equal to 6. 6 square is equal to 36. As you can see, the 6 is raised 2 times to get 36. And let's take another, log 1000 to the base 10. Okay, now here we should find how many times the 10 is raised to get 1000. 10 power of 1 is equal to 10. 10 square is 100. 10 cube is 1000. So here as you can see this 10 is raised 3 times to get 1000. Okay, so now in lower classes we studied about the loss of exponents, right? So here till here we clear, right? We are clear. What? First they gave exponential forms. So now we took some exponential forms and then we expressed them in logarithmic numbers. Okay, so here we took some more logarithmic numbers and expressed in exponential form. So here we are able to now we are able to express this exponential forms to logarithmic forms and logarithmic forms to exponential forms. So let's revise the loss of exponents we studied in lower classes. This loss of exponent will be useful in solving the problems of exercise 5.1, sorry 1.5. okay, this loss of exponent. Okay, let's revise loss of exponents. Loss of exponents, and we have loss of logarithm also, do you know? Okay, let's know about this. Loss of exponents. First law is a to the power of m into a to the power of n is equal to, when the bases are same, the exponents are added, right? Here this is one formula, this one law, and second law a to the power of m into b to the power of m. Then it will become ab whole power m. As you can see, when the bases are same, the exponents are different, then we should add the exponents. When the bases are different and exponents are same, then we should multiply the bases and exponent will be whole. Should multiply the base and exponents. Okay, and the third one will be a to the power of m whole to the power of n. Then it will become a power mn. Okay, so the fourth one is, yeah, 1 minute. Yeah, it's clear. So let's take another number. Sorry, let's revise another law. What is it? Division a power m by a power n, then it is equal to a power m minus n. In division, when the bases are same and exponents are different, then they are subtracted. When in multiplication, when the bases are same but the exponents are different, then they are added. Okay, remember that. Here in multiplication, when the exponents are different, then added. In division, when the exponents are different, then they are subtracted. Okay, let's take another. Okay, let's take a power m by a b power m, then it is equal to a by b whole power m. Right, do you remember? This is a law, right? When the bases are different and the exponents are same, then they are multiplied. Here also same, when multiplication also same process here also. Then the m will become a by b whole power m. Okay, the sixth one is here. Then 1 by a to the power of n is equal to, so here when a number is in the form of, when an exponent is in the form of 1 by a to the power of n, then it can also be written as a to the power of minus n. Okay, the seventh one is a to the power of 0 is equal to, remember this is very useful, a to the power of a to the power of 0 is equal to 1. The eighth one is root a is equal to, means it can also be written as a to the power 1 by 2. Okay, remember that. Okay, now these are the laws of exponents, and now we are going to study about the laws of logarithms. Okay, so here first there are 3 rules for this. That means we have 6 laws for this, and we have 3 rules. Rule 1, power of rule. This is power rule. This is power rule. Okay, so here in power rule we have 3 laws. Let's write them. So here log a to the power of m to the base b is equal to m whole m into log a to the base b. Okay, here when there is exponent for logarithmic number, not to this. Okay, when there is exponent for logarithmic number, then that goes out here. Okay, that goes out as it is, and now the rest will be as it is. So here when uh, when this logarithmic number having exponent, then it goes out and multiplies. Okay, multiplies the logarithmic number. Okay, so here the logarithmic number is multiplied by m. Okay, so now let's know the second one. Log a to the power to the base b power m is equal to 1 by m by into log a to the base b. Okay, first clear that here when logarithmic number is having exponent, then it goes out and multiplies. Okay, here when the logarithmic number base have exponent, it goes out and first it will be goes out and multiplies reciprocal. Here we have the power is m. When it goes out and multiplies, it will become as a reciprocal. Okay, so now let's write. Let's know the third law. Log a power m to the base b power y. Okay, here you should concentrate on this very deeply. Okay, so here when we have base and logarithmic number have exponents, they divides both and multiplies the logarithmic number. Okay, so now let's write that m by y by into log a to the base b. Okay, here concentrate. Here what you are doing, log a to the power of m to the base b to the power of y. Here we have when the base and logarithmic numbers have exponents, they both divide themselves. Okay, here m and y divided and that multiplies the logarithmic number. This logarithmic number whole is multiplied by this. Okay, you understand? So here the rule 1 is power rule, and we have studied 3 laws under this. What are they? When we have exponent to the logarithmic number, then it goes out and multiplies the whole logarithmic number. And here the log a to the base b power m. When there is exponent for base, then it goes out but reciprocally multiplies the logarithmic number. And here when we have logarithmic number and base by powers, then the powers will divide themselves and multiplies the logarithmic number. Okay, it's clear. So now let's know the rule 2. Yeah, let's know the rule 2. Rule 2 is multiplication rule. Log AB is equal to log A plus log B. One minute. Yeah. Okay. Here the log A into B is equal to log A plus B. It is okay. Here when the logarithm, here we don't have any base. Okay, the logarithmic numbers only we have. The logarithmic number A into B is equal to log A plus log B. As you see here, when the bases are same, then the exponents are added here, we can assume the base. If we don't have any base, we can assume them as 10. Okay, we can assume them as 10 when the bases are same. Okay, here we are not going to the loss of exponent, only we are having that when we have log ab, means n to b, then it can also be written as log a plus log b. Okay, okay, here we can use this rule, this law in solving the problems of 1.5 reversely also. Okay, if we have the number in the form of this, then we can write in this. If we have number in this form log ab, then we can write this in this form. Okay, now let's know rule 3. This is division, sorry, yeah, divisions, and here log a by b is equal to log a minus log b. Okay, when the logarithmic numbers are divided, then the result will be log a, then the result will subtracted. Okay, log a minus log b. When the logarithmic numbers are multiplied, the result will be added. When the logarithmic numbers are divided, then the result will be subtracted. Okay, remember. Okay, so now let's know these 3 rules are main, and we have two more laws. So yeah, we have 3 more laws. Let's know that log a to the base a is equal to 1 when, okay, here you should carefully observe that when the logarithmic number and base are same, then they are equal to 1. Okay, remember, when the logarithmic number and the base is equal, then the logarithmic number total will become 1. Okay, so now let's know another law. When, okay, log 1 is equal to 0. Okay, here you should remember, when the logarithmic number and base are equal, then it is equal to 1. When the logarithmic number is 1. Okay, when here if we have log 1 to the base 5, here the value will be 0. When the logarithmic number is 1, then the whole number will be equal to 0. Okay, so when, okay, now let's know the other law. A to the power of log x to the base a is equal to x. Here it is difficult, but don't assume that is difficult. It is very easy if you concentrate on this. Here this log a is having a power with log. Here the log is log x to the base a. When we have this type of number, then the logarithmic number will become as the result for this. Okay, here if we take some, so now let's understand this by taking an example. Okay, 2 to the power of log, oh, okay, let's take 16, and to the base 2, then this total will be equal to 16. Okay, here when this log is in powers, okay, here as you see this number this 2 is having the power as logs, then the logarithmic number will become as a result for this. Okay, remember that. Okay, now let's solve the questions of exercise 1.5. Okay, let's solve the problems of exercise 1.5. Till here you are clear, right? What we here the laws of logarithms are nothing but we have 3 rules. Okay, on the first rule we have 3 laws. Okay, under first rule we have 3 laws. What are they? When we have exponent for the logarithmic number, then that goes out as it is, and when we have exponent for the base, then it reciprocal and multiplies the logarithmic number. And if we have both both numbers have, means the base and logarithmic number have exponent, then they are divided and multiplies the logarithmic number. Okay, understand? Here the multiplication rule, and here the log AB is equal to the log AB is equal to log A plus log B. Here we can assume if there is no base, then we can assume as 10. Okay, here we assumed as 10. Okay, log AB, when the logarithmic numbers are multiplied, then the result will be added, and when the logarithmic numbers are divided, then the result will be subtracted. And when we have the logarithmic number and the base is equal, then the total value will be equal to 1. And when logarithmic number is 1, then it is equal to 0. Carefully understand. Okay, here when the logarithmic numbers are in powers, okay, here we have this A is having the exponent as logarithmic number. When the logarithmic number is in powers, then the logarithmic number will become as a result. Here we assume that thing. Here 2 log to the power of log 16 to the base 2 is equal to 16. Here the x will become as a result. Okay, so now let's solve the problems of exercise 1.5. Okay, the first question is determine the value of the following. Okay, now here we should determine the value of the given Romans. We have 9 Romans. Let's solve all of them. Okay, the first one is log 5 to the base 25. Okay, yeah, here the question is log 5 to the base 25. Let's write log 5 to the base 25. Here we should find the value of this. Do you observe that this 25 is the square of 5, right? This 25 is the square of 5. So here let's write log 5 to the base 5 square is equal to, here you can observe this can be written in this form also. This 25 is square of 5. So here we wrote 5 square. As you can see, when we have exponent for base, then that reciprocals and multiplies the logarithmic number, right? So here we can write in that form. Okay, let's write. Here we are using log A to the base b power m is equal to 1 by m by into log A to the base b. Okay, here we are using this law and simplifying this to get the value. Okay, here now we should transfer this 2 to here. What it becomes reciprocals, and now log 5 to the base 5, right? Here that multiplies. As you see, first we should concentrate on this only. Okay, if our mind is on movies or something else, we can't focus here. Okay, if you are seeing a serial or a movie, then how can we solve this? So now we should full concentrate on the problems we are doing, then we can get the correct value. If you are doing, if you are eating, and if you are watching the movie, then how can you focus? The focus will be on the movie, right? So here of the TV and listen here. Okay, here this logarithmic number is in the form here, this log, right? Log this, here the logarithmic number and base are equal, right? Here also the logarithmic number and base are equal, then the whole number will be equal to what? 1. So here let's write that 1 by 2 by 1, then it is equal to 1 by 2. So here the log 5 to the base 25 value is half, 1 by 2. Okay, so now let's solve the second one. The second one is log, in 1 minute. The second one is log 3 to the base 81, and we should find the value for this logarithmic number. Okay, so here let's write the number log 3 to the base 81. Here concentrate on this. Here this 81 can be written in the form of 3 cube. So this 81 is a cube of 3. Okay, so here when they give this base as largest numbers, and you should know whether they are multiplied by the logarithmic number or not. So here we have 5 and the logarithmic number is 5. So here this number is multiplied by 5. So here we wrote 5 square, right? Here also we should know the cube values, square values, to the power of 4 values, to the power of 5 values for all the numbers minimum. Then we can solve this very easily. So here this can be written in the form of log 3 to the base 3 cube. We are a little bit confused right here. The all are 3's, right? So yeah. Okay, now let's assume we are using this law and finding the value. So here let's write that a log a to the base b power m, then it is equal to 1 by m into log a to the base b. Okay, here we have exponent for the base, so here that comes out and becomes reciprocal, means 1 by 3. Then we can into this logarithmic number log 3 to the base 3. We are left over with this, right? 1 3 comes out. Here what will be there? 3 3 here. So here do you observe that this is the base and logarithmic number are equal, then the value will be equal to 1. Then we can write this 1 by 3. 1 by 3 into 1, what is 1 by 3? The value is become 1 by 3. Okay, they are very easy, right? Yeah. Okay, now let's take the third. Okay, the third question. Okay, the third question is log 1 by 16 to the base 2. Okay, here now let's find the value for this logarithmic number. Okay, here log 1 by 16 to the base 2. Here as you see, here this is in the division form. Okay, so here you can keenly observe that log a by b, log 1 by 16, same, right? Now let's write the result in the form of subtraction. Log, here what is a? 1 to the base 2 minus log, here what is the b? 16 to the base 2. So here we applied the log a b, sorry, a by b, and it is equal to log a minus log b. Okay, here we apply this law for this, and here as you see, this is the logarithmic number value is what? 1. So here do you observe the logarithmic number? If we have the logarithmic number as 1, then it is equal to 0. So here this is also equal to 0. We have 1, right, logarithmic number. So here minus log. So here do you observe this 16 can be written as 2 to the power of 4, right? And this 16 can be written in the form 2 to the power of 4 and the base 2, right? So here let's, okay, here as you see, 1 minute, as you see here we have a law. What is it? Log a power m b is equal to m log a to the base b. We have, right? We have or not? Yeah, we have. Yeah, when we have base, sorry, when we have exponent for the logarithmic number, then we should take it out and the multiplies the logarithmic number. Okay, so now let's take it out. Minus 4 log 2 to the base 2. Here you can observe that this is in the form the base and all the logarithmic numbers are equal, then they are equal to 1, right? Log a to the base a is equal to 1. Okay, so here then the value will become minus 4 into 1 is equal to minus 4. Here the value for this third one is the third equation. This log 1 by 16 to the base 2 is minus 4. Okay, let's take the fourth one. The fourth question is find the value of log 1 to the base 7. So by seeing only you can answer this, right? What? The logarithmic number is 1, then it is equal to 0, right? Here by seeing only you can answer that, right? Okay, here the fifth question is log root x to the base x. Okay, here as you see, this log, don't scare by seeing root here in logarithmic numbers. This root can be written, we have the loss of exponents, right? Here this can be written in the form of half when we have square root. Here this can also be written in form 1 by 2 log x 1 to the power of 1 by 2 to the base x. Okay, here we apply the loss of exponent. What? root a is equal to a to the power of half. Okay, this law we used here, and here we have the power for logarithmic number, right? Here this power goes out half, and here log x to the base a. Here as you can see this is equal to 1, so here the answer will be half, right? Okay, it is very easy. Comparing to all, this is very easy. Okay, the sixth one is let's do fast. Okay, here you can do for yourself. Okay, the sixth one is very easy. It can be written in the form 2 power 9. So here I gave all the answer for this. Okay, you can write that. Here the 512 can be written in the form 2 power 9. You can solve that question. Okay, now I am going to solve the seventh one. Log 0.01 to the base 10. Here don't confuse your mind by seeing 0 points in logarithmic numbers. Okay, here we can write this points number as decimal form, the p by q form, right? So here let's write log this 0.01 can be written in 1 by 100 to the base 10. Okay, it's very clear. Here we can apply the law. Log a by b is equal to log a minus log b. Right. Here let's write that. Log the a is 1 to the base 10 is minus log 100 to the base 10. Here as you see this is equal to 0 because logarithmic number is 1. And here this 100 can be written as square, 10 square. Here we have exponent for logarithmic logarithmic number, then this goes out. Minus 2 into log 10 to the base 10, then the value will be minus 2. Okay, observe that, you can understand very clearly. And let's solve eighth one. The eighth one is log log 8 by 27 2 by 3. Okay, here as you see, okay, here you can observe that they are both are in rational number form, but don't confuse here, because as you know that 8 is the cube of 2 and 27 is the cube of 3, then we can write them as log 2 by 3 whole power cube to the base 2 by 3, right? So here we have exponent for the logarithmic number and it is equal to, then this goes out and multiplies the logarithmic number. Log 2 by 3 by 2 by 3. As you can see, here the logarithmic number and the base are equal, then it is equal to 1. So here the value will be 3. Observe this. Here this is 8 is the cube of 2, and here the 27 is the cube of 3. Okay, let's solve the ninth one. This ninth one is very easy, comparing all of them. We have 2 square plus log 3 to the base 2. Okay, here as you observe, this is in the form, 1 minute, let's write that 2 square plus log to the log, sorry, here. So okay, let's write 2 square plus log 3 to the base 2. As you can see, here they are added. It means we can write them as a power m into a power n, a power m into n plus n, right? Okay, let's write 2 square plus 2 log 3 to the base 2. Here do you observe that this is in the form of this, right? So here the value will become as a logarithmic number is a result. So here the logarithmic number, what is it? 3. So here that will become as the result. 2 square is nothing but 4 and 3 is the logarithmic number is 3. So here the value will become 4 plus 3, then it is equal to 7. So here the value is 7. Okay, this is for today, and in next part we are going to solve all problems from 2 to 9. We have 9 questions and we completed one, and in next video we are going to complete all, and we are going to complete our chapter also. Thank you for watching. Like and share this video. For more interesting videos, please subscribe our channel and do check it out.